Hey guys, this is Miss Jones. We are going to talk today about air pressure, temperature, and the environment. Let's get started. So, air pressure, or some people call it atmospheric pressure, refers to the weight of the Earth's atmosphere pressing down on everything at the surface. You can also kind of feel it when someone grabs your arm and you feel the pressure when they grab your arm. That's because the molecules collide with each other and things like your arm, the ground, or a tree. They exert a force on those surfaces that air has pressure too. One of the things that's most important to know is that air has weight. So the force of the molecules in motion causes the air pressure. So the next thing we're going to talk about is things that affect air pressure. There are three things that affect air pressure, and we like to call it by an acronym of HAT. So humidity, altitude, and temperature. So humidity is the moisture in the air. The altitude is the elevation of the air, and the temperature is the hotness of the air. So if you remember HAT, then you can remember those three things that affect it. So like as the heat goes up, air pressure goes down. All of them have the opposite relationship. So the next thing we're going to talk about is humidity. So as you're looking at humidity, that's the amount of moisture that we have in the air. You know, those hot, muggy days when you feel like it's going to rain or something like that, that's because there's a lot of humidity. So there's a lot of moisture in the air. So water vapors weigh less than air molecules. So if you're looking at this, remember what we were talking about earlier. If you're looking at the picture on the right hand side of the, looks like a desert, and you see that as long as the humidity is down, then the air pressure is going to be up. Okay, so that means there's going to be less moisture in the air. So if you look at the next picture where you see it looks like kind of a rainforest, whereas the humidity is going to be up, the air pressure is going to be down because there's going to be less moisture in the air because all of it's falling to the ground. So how do we do that? So air contains oxygen and nitrogen, which oxygen is related as O2, and it's 16 times 2, which equals 32 molecules of oxygen in the air. And nitrogen is 14 times 2, which is 28. So your water vapor is made up of one oxygen, which is 16, and two hydrogens, which are 1, but it's going to be 2 of them. So therefore your oxygen is equal to 32, your nitrogen is equal to 28, and your water vapor is equal to 18. So that shows that your water vapor weighs less than the molecules that are already in the air, such as the oxygen and nitrogen. So as the air becomes more humid, the air pressure is going to go down because moist air weighs less than dry air. Interesting. So we want to know a little bit about dew point. So dew point is when air cools to its dew point through contact with a surface that is cooler than the air. Water will condensate on the surface. So if you're in like your house and you have your air conditioner running and it's kind of really hot outside, so we're cooling down the air, and when it touches that surface of the window, you see the condensation on the windows. So that is what is called talking about the dew point. So next we're going to talk about altitude. So altitude is, the higher the altitude, the lower the air pressure. It's kind of the same thing as what we were talking about earlier. it's always the opposite of the other. So when you're higher, sorry, my pencil's not working. When you're higher, well, let me get it working, guys, sorry. When you're higher in the altitude, you're lower the air pressure. So when you're lower in the altitude, you're higher in the air pressure. So if you look at this picture down here, there's a kind of, it looks kind of like, I'm going to say it's like a mountain or a volcano, it could be. But if you look right here, that's going to be lower the altitude because it's up higher in the air. So you're going to have the lower air pressure. So if it's higher in the altitude, it's going to have a lower pressure. And then if you look here, it's going to be lower in the altitude, so you're going to have higher air pressure. Okay. Sorry, this keeps coming up. Okay, so the next thing we're going to talk about is temperature. So if you look at temperature, as long as the temperature goes up, the air pressure is going to go down. Remember, everything's opposite of the air pressure. So hot molecules are further apart because there's less pressure. So like your heat is going to go up. Oops, sorry. Oops, went to the wrong one. Let me go back. Sorry. Sorry, guys. I'm still learning how to use this. So as your temperature goes up, then your air pressure is going to go down, and as the coolness of the ice is going to be colder, your air pressure is going to go up. Sorry, I'm not drawing very well in here. So remember, as the temperature goes up, the air pressure goes down. Hot molecules are further apart because they have less pressure. As the temperature goes down, the air pressure goes up. So cold air is more dense than warm air, and its molecules are closer together. They have more pressure. So if you look at the picture down here at the bottom, right down here, you'll see that in dense air you have less molecules. So the warm air, you want to you're really, when you're really hot and you're sweaty and you don't want anybody to touch you, you have less, you have a lower pressure and less dense, so your molecules are kind of spread apart, so you don't want anybody touching you. But then when you're cold, you want to cuddle with someone because you want everyone to get close together. So that's kind of what these look like. So you're more dense when it's cold air. Sorry, this keeps coming up. I'm going to figure this out eventually. So the next thing we're going to talk about is environmental issues. So environmental issues fall into 3 categories: resource use, population growth, and pollution. So let's talk about the first one, which is resource issues. So resources are anything in the environment that is used by people. So we have 2 types of resource issues. One is renewable and one is non-renewable. So renewable resources are always available or naturally replaced in a relatively short period of time, such as sunlight, wind, fresh water, trees. So like when you have solar panels on your house, that's actually a renewable resource because every time the sun shines on those panels, it makes the electricity for your house. So that's kind of like a renewable resource. Then you have non-renewable resources, which they are not replaced in a useful time frame, such as coal or oil. So when we drill for oil, it doesn't come back, or it doesn't come back quickly. It takes years and years and years for that oil to develop, if any at all. So some people feel like renewable resources will never go away, but that's not necessarily the case. That's actually false, because when you're cutting down trees, even though they're a renewable resource because they'll grow back, but when you're cutting them down faster than they grow, then it can become a non-renewable resource because it doesn't get replaced in a quick amount of time. So the next thing we're going to talk about is population growth. So the population over the last over the last 3,000 years has really increased a lot. So why does this matter? Because the demand for resources has increases. So you need more food, you need more places to live because you have more people, you're going to need more cars, you're going to need more jobs. So it's just kind of, as the demand goes up, the resources have to increase. So we don't want to cut down all the trees in neighborhoods because then we'll be not using our resources, but we also need more houses. So we have to find the land for that. Like, for example, for water shortages, towns restrict water use because areas of fast growth do not have the facilities for such large populations. So, like a couple of years ago in Cary, they put restrictions on when you could use your water. So they said, like, one side of the street could use it on Monday, Wednesday, one side could use it on Tuesday and Thursday. And if you used it on the day that you weren't supposed to, you could get fined because they had their population grew so fast, they did not have the facilities to make the water that they needed for everyone to use. So then we're going to talk about the third thing, which is pollution. So pollution is the contamination of Earth's land, water, or air. It can be caused by waste, chemicals, heat, noise, light. We hear a lot about burning of fossil fuels. So the burning of gasoline, which is a fossil fuel, releases pollutants into the air. So the more cars that are on the road, the more gas we use, the more pollutants that are released into the air. So it's kind of like a vicious cycle because you need more of these things. You have to burn more of these things, and it just causes a lot of contamination in the air. So as the population grows, we need to be fed more. So we've got to have more fertilizer and other chemicals that we use to produce food, or you have to have more land to do that. Chemicals run off the land and pollute the bodies of water. So when you see the farms around that have used chemicals, so they've got these chemicals, and then when it rains, it falls. The chemicals run off the land into our water supplies and can contaminate our water supplies. So it's very interesting. So sorry. Okay. So the next thing we're going to talk about is how we're making these environmental decisions. So we have to always balance the decisions about the environment with whether it's making money or not, or where the need is. So we have to kind of look, or people who are in government have to kind of look at these things to decide what is the right way to do it. So the balancing needs is called environmental science. It's the study of natural processes in the environment and how humans can affect them. So we need to help balance the different options on an environmental issue. Decision makers weigh the costs and the benefits of proposals. So when you have to do things, you have to look at all these things. So the costs and the benefits are one of the main things that they look at for the environmental decision. So long-term effects on the environment and the economy. And an example of that would be cutting down trees changes the ecosystem but provides jobs. So you have to kind of look at it as if you cut down the trees or the forests, then you don't have your animal habitats. But you also need to cut them down to build the houses, which will provide jobs and places for people to live. So it's kind of a decision that they have to make. They have to look at both sides. Then I want you to think about, what are the costs of drilling oil in Antarctica? So you've got your negative and your positive things about it. So one of the things is you get jobs and we have resources. So what are the benefits of it? Well, the jobs and the resources. But drilling in the Antarctica could also cause an environmental issues, such as ice caps melting and causing other issues that we don't really want to deal with. So you have to kind of weigh both of them when you think about it. So the next thing we're going to talk about is the ozone layer and how it impacts us. So the ozone layer protects us from sunburn, eye disease, and skin cancer. So the ozone layer, the highest part is in the stratosphere. So it can be helpful or hurtful depending on its location. So when it's up in the stratosphere, it's actually helpful to us because it's higher in the atmosphere where we can't breathe. So that's helpful. So the pollutants that are closer to us that are in the troposphere, which is the smog. So depending on where the location of the ozone is, it can either be helpful or hurtful. So if it's a pollutant in the form of smog on Earth's surface, then it's harmful to us. If it's higher in the atmosphere where we can't breathe, then it's helpful. So it's kind of one of those, crazy things that we think about, whether it's good or bad. So, when it's hot and muggy, the ozone protects us from showing that that's kind of the greenhouse effect for that. So the sources of the ozone is created when the sunlight strikes an ozone molecule. The molecule then breaks into oxygen molecule and oxygen atom. They eventually bond with other oxygen atoms and molecules to form new ozone molecules. So when sunlight is absorbed by the ozone, it doesn't reach Earth's surface. So okay, so the next thing we're going to talk about is the ozone hole. So this is interesting because oxygen has been thinning since the 1970s in the Antarctica, which means that the amount of ozone has been decreasing, letting oxygen escape and letting UV rays in our atmosphere. So what has caused this? Well, the major cause is the human gas called CFCs, or fluorocarbons. They've been used in household items such as air conditioners, aerosol cans, and other things that we use, but and you didn't really think about that when we were first doing it. So how does it affect it? It's because when the CFCs hit the ozone molecules, it blocks the absorption of UV lights. So back in the 1990s, because we knew about this and it started causing issues, the 1990s, they signed an agreement to not use CFCs. So by the year 2000, all CFCs were banned. So the problem is that we were using them before that. And so some CFCs are still used, but most don't reach the atmosphere. Unfortunately, they remain in the atmosphere for a while, so researchers have the technology to decrease the amount of CFCs released from man-made machines. So we still have machines that are use CFCs, but they've created this type of technology that will help decrease it. Now, we are going to talk about global climate change. So you've probably all heard about the greenhouse effect and global warming, but let's go and talk about it a little bit more. So the greenhouse effect is the trapping of heat near Earth's surface. So water vapor, carbon dioxide, and other gases act as windows to the atmosphere by allowing light to hit Earth's surface, but preventing heat from escaping into space. Too much of these gases could lead to too much heat being trapped. The atmosphere would then absorb UV radiation released by the Earth. Without this, our planet would be much colder and all Earth's water would be frozen. So, you know how when you're in a greenhouse, or I don't know if you ever watched the movie Santa Claus Coming to Town, I think it was, but he got stuck in a greenhouse and he melted. That's what the greenhouse effect does. So if we didn't have the greenhouse effect, then basically we would all live in the Ice Age. So the next thing is global warming. So the global warming is a prediction that increases in carbon dioxide that the increase in carbon dioxide will cause average temperatures to rise. Because of activities such as coal and oil burning, CO2 amounts have increased 280 parts per million to 350 parts per million and are still increasing. Human activities that increase CO2 could be increasing the greenhouse effect. So there's a lot of controversy today about global warming and what it's going to cause for, the world in general. Saying our polar ice caps are melting and could be good or bad for the environment. So they kind of want to watch what's going on in the global warming. So the last thing we're going to talk about is climate change. So what could happen if temperatures rise? What we were talking about earlier. Antarctica ice caps would melt, which would raise ocean levels and cause flooding. So we all know that what flooding means because we've just seen it with Hurricane Florence coming and how water and ocean levels rise and cause a lot of damaging floods. So climate patterns will be disrupted and changes where we could grow crops, an increase in hurricanes and severe storms could be possible. So we know that as all this happens, it can cause more weather issues. So why is it difficult to predict climate change? Because all these systems are so complex. Volcanoes, forests, and oceans affect CO2 levels. It's hard to pinpoint how each of these factors would affect the climate. Computer models help scientists predict these changes. So, when meteorologists are all doing their stuff, they're looking to see how they can figure out how to predict where the climate will change and where the hurricane will go, where the flooding will be. But it's not an exact science, and we're all still just figuring it out. But that's all I have for you today. And if you have any questions, just talk to me in class. Talk to you soon. Bye.